7.2, we are going to take a look at multiplying polynomials. And in this lesson, we are going to work on multiplying polynomials so that we will be able to simplify an expression where two quantities are being multiplied. And you'll be able to do this when you can get an expression to be written in its simplest form. So just a little reminder here, polynomial quantities are often grouped together in parentheses. So for example, and I have some ridiculous examples here, but this is a polynomial quantity. This is a binomial. And binomial is just that there's two terms and they're being separated by an addition or a subtraction. So 2x is a term and 4 is a term, and they are being added together. That is a group, a quantity, 2x plus 4. So this would be a binomial. A trinomial has three terms. So we have 8x to the second power, we have negative 3x, and we have positive 13. So that is a trinomial. There are three terms. And then here we have, this is just a polynomial, where anything kind of larger than three terms, we just say poly, which means many. So 892w to the 76th power, positive 252g to the 98th power, negative 37b, positive 85u, and negative 2. That's just a bunch of terms that are grouped together inside parentheses, okay? So these quantities can be added and subtracted just like we learned in 7.1. So remember, if we think back to 7.1, you would have something like 2x to the third plus 3x squared minus x plus 17. And then we would add that quantity. Sorry, I didn't leave enough room to really write this example. So we could say plus this quantity here. Let's say 3x to the third plus 7. I don't know, a binomial. Okay, and then that addition is telling us that we're going to take whatever is in this group as it is, and it's going to get added to its like term in this group. And then you learned in 7.1 that we could also subtract. So if we have minus, that we're actually going to take the opposite of 3x to the third. So we would use a negative 3x to the third and combine it. And then the opposite of positive 7. So that negative kind of distributes in and changes the sign. When we're subtracting, it means the opposite of. So if we're paying attention to our operations, we can add, we can subtract, and what we're going to talk about today is what happens when we multiply. And here's what multiplying polynomial would look like. It's when we have two parentheses next to each other. So think about if I have an expression written like this. This means 2 times 3 because my parentheses are just sitting next to each other. I don't need to indicate like a multiplication sign, right? Like that, when we see two parentheses sitting next to each other, we know that that means to multiply. So we are going to learn how to multiply polynomials today. There are going to be three different ways that I'm going to show you today. So we know that quantities can be added or subtracted. They can also be multiplied. So that's our first quantity times our second quantity. And there are several ways to multiply these. So I'm going to show you the area model, which is also called the Punnett square, rectangles, a few different names for this. So I'm going to show you how to do that. There's also double distribution. And when we're doing double distribution with binomials, you may have heard it as foiling, which is first term times first term, outside terms times each other, inside terms times each other, and last. If you're familiar with FOIL, great. If not, don't worry about it. I'll just kind of show you what that double distribution looks like. And then there's expanded. I'm going to show you how to do this with expanded. So what you'll see here are, I have 6 examples of each. Now in this video, I'm not going to do all 6 every time. What I'm going to do is I'm going to do the first 3, and then if you would like some extra practice, you're more than welcome to go back and practice with these. And what you're going to see here as well is that the first 3 that I do, I believe, are all the similar numbers in each thing. So I'm going to get the same answer every time when I'm working these out, but I'm going to show you 3 different ways to do them, okay? And so for our area model, you may want to just put a little note here that this is using boxes. So we're going to multiply using boxes. Double distribution, well, we'll get there. Okay, let's just start here. So the area model, I'm going to use boxes. And so I'm going to look here. And actually, real quick before I do this, just a little reminder of some rules. So when we're multiplying, our base numbers multiply. So if I had like 2x to the 4th, and I multiplied that term with negative 6 x to the 2nd. Okay, a little reminder from last semester, we're going to multiply up our base numbers and follow our sign rules. So a base of 2 times a base of negative 6, 2 times negative 6 is going to give us negative 12. So I have base numbers that are just going to multiply. And then what our exponent rules, when we're working with our exponents, when we're multiplying them, we are going to add our exponents up. So I'm going to get x to the 6th. That is 4 plus 2. So 4 plus 2 makes 6. My base numbers was 2 times negative 6, which is negative 12. So that's just some math, like calculation skills that you need for doing these. If you're comfortable multiplying these, you'll be good in these models. Just pick whichever one works best for you, but I want to show you several different ways. So the first one is the area model, which means I have 2 terms. So I'm going to give myself 2 terms here. I have v and I have negative 1. And those are going to multiply with my other 2 terms, 3v and negative 4. So with the area model, what we do is we take our first 2 terms, we list them on the side. We take our other terms and we list them on top. And they're you have to leave your groups with each other. So my whole group has to go on the side. My whole group has to go on the side. But if I put 3v minus 4 on this, and I put v minus 1 up here, that would be fine. Okay, you would end up getting the same answer. So now what we're going to do is each box is going to be made, or we're going to find what goes in each box by taking our outside term and multiplying it with the corresponding outside term. So for this one, I'm doing v times 3v, and that's going to be 3v to the 2nd power. Again, kind of going back to our exponent rules, multiplying exponents up there. That's v to the 1st and v to the 1st. 1 plus 1 is 2. I have 1 times 3, which was 3. So I have 3v to the 2nd power. Now I'm going to take this v, and it's going to multiply with negative 4. So v times negative 4 would make negative 4v. Down below, I have negative 1, and that is multiplying with 3v. So I'm doing negative 1 times 3v. Negative 1 times 3 is negative 3, and there's nothing multiplying with the v to change it, so it's just going to stay as v. And then finally, I have negative 1 and negative 4, so negative 1 times negative 4 would make positive 4. Okay, so essentially you're taking your outsides. It's like your Punnett squares from biology when you were working with, the alleles or the dominant and recessive traits, and you would figure out what those were doing based on the boxes that they created. So kind of similar. So we're almost done. This is just a way of organizing our work. Now I'm going to combine like terms. When we build these boxes out, our diagonals are going to be like terms. So 3v to the second has no other v to the seconds to combine with. So 3v to the second is just going to stay 3v to the second power. Diagonally, I have a negative 3v and a negative 4v, and so those are going to combine to give me a total of negative 7v's. So when we're working within the boxes, we are adding or subtracting, and we're just counting up, so it's not going to affect our exponents. When we were multiplying to get our values in the boxes, those we followed our rules to change or affect the variables and the exponents. So a couple different rules to keep in mind, but those you've learned how to do everything here. We're just putting it together and organizing it. And then finally, this positive 4 doesn't have any other constant terms to go with, so this stays as plus 4. And this is our answer. It's in simplest form. Okay? So I'm kind of thinking through what's going to be the best way to do this. I'm going to do all of the boxes first. Then I'm going to go down and show you how to do it with double distribution, and then I'll show you how to do it with expanded. So here's my next box. I'm going to have two terms here. So I'm going to do 7x and 6. I'm going to have three terms on top. 6x squared, a negative 3x, and a negative 4. Notice how many boxes it made. Okay, so now I'm just doing one piece at a time. I'm going to do 7x times 6x squared. So I'll do my base numbers first. 7 times 6, let's do this in blue, 42. And x to the first and x to the second makes x to the third. Okay, I'm gonna work across the top. Obviously, you could kind of just fill this out whatever way you want to, but I'm just going to work across the top, then I'm going to work across the bottom. So now I'm doing 7x times negative 3x. So I'm going to do 7 times negative 3 to get negative 21. And I'm doing x to the first and x to the first to get x to the second. And then in my last box, I'm doing 7x times negative 4. 7 times negative 4 is negative 28. And x to the first doesn't have anything that's changing it, so it just stays x to the first. If you want to write a 1 in, you can, but it's not necessary. Okay, here's our next box. We are doing along the bottom 6 times 6x squared, so 6 times 6, 36. And our x values, if you see there's no x attached to this 6, so it's just going to stay as x squared here. Okay, so base numbers, 6 times negative 3, negative 18, and nothing changing the x, so that stays as x to the first. and then 6 times negative 4, negative 24. Okay, so I'm going to do some highlighting here, and what you're going to notice, I'm going to highlight my like terms in the same color. Let's do something that looks different. Really have great looking different colors here. Yellow, I guess. I rarely use yellow. Okay. So do you notice that our diagonals are like terms? And these guys don't have like terms. So I have, in purple, 42 x to the third. And then from my greens, I'm doing 36 minus 21, which will give us positive 15 x squared. I have a negative 18 and a negative 28, so I'm going to add those up and keep the sign. That's going to give me a negative 8 and 8 makes 16, carry the 1, and that's going to give me 46x, and then my negative 24 didn't have anybody. There we go. Just move that over, maybe make it a little smaller so that line's not cutting right through it. But that's our solution right there. Okay? That is simplified. Your simplified version is only going to have one of each kind of term. So all of our like terms, there's only one of each. Okay? And then I'm going to show you C. So C is if we have 3 terms times 3 terms. So I'm going to take 5x to the second. We have a negative 7x, and we have a positive 8. And then across the top, I have 3x to the second. I have a positive 2x. I have a negative 3. And then I can draw lines in between each of them. Okay, and then I'm just multiplying 9 different times to fill in each of these boxes. So 5 times 3 is 15. Let me do a different color so this isn't just a bunch of black scribbles on here. 5 times 3 is 15. x2 and x2 makes x4. 5 times 2 is 10. x2 and x1 make x3. And 5 times negative 3 is negative 15. And x2 doesn't have anything that's changing it, so it stays as x to the second power. My next row, negative 7 times 3, negative 21. x1 and x2 make x3. My middle here, I have negative 7 times 2, negative 14. x1 and x1 make x2. So I'm doing my base numbers, and then I'm working out my exponents. Negative 7 times 3, positive 21. And then x and nothing just stays as x. And finally in the bottom here, 3 times 8 is 24, x squared. 2 times 8 is 16, x. And 8 times negative 3 is negative 24. Okay, so this one is kind of a lot of writing, but what you notice is it organizes your work pretty nice. I'm going to get a purple answer here. These are like terms. I'm going to get a green answer here. These are all like terms. So I'm going to put all 3 of those together and get a red answer here. 16 and 21. I'm going to put those together and get an orange answer. And finally, let's go with one of these. How about light purple? This guy doesn't have anybody, so I'm going to get that answer there. Okay. So now I just go through and I'm adding these up. 15x to the fourth doesn't have anything. Negative 21 and positive 10. I'm just counting these up, so I'm not really even worried about my exponents or anything like that. I'm just counting up. So negative 21, positive 10 will give us negative 11. And then we combine all these. I'm going to say 24 minus 14, which is 10, minus 15 is negative 5. And I'm kind of doing these quick and worried more about explaining them than calculating them. So if I did anything off there, have a little grace for me. So 1 and 6 is 7, 2 and 1 is 3, and that was positive. Each one of these will be separated by a sign, and then negative 24. So here's our answer. So if you are a very visual person and like to see the numbers and kind of create a chart to organize, this is a good way to do it, and that's the area model. So now I'm going to solve the same three problems, but I'm going to show you how to do it with double distribution. And personally for me, when I do double distribution, I'm going to line, so these are like the rainbows. This is like when we're doing the rainbows. So for this one, I'm going to line up my answers based on like terms, and you'll see what I mean in a moment here. So I'm going to do blue. V times 3v is going to give me 3v to the second power. V times negative 4 is going to give me negative 4v. So I take my first term and I distribute. Then in red, I'm going to take my second term and distribute. So my second term was negative 1, so negative 1 times 3v is negative 3v. And I'm going to write that underneath my 4v because they are like terms. And then negative 1 times negative 4 is positive 4. I personally like this way. This is how I do them personally. One, I'm kind of lazy. This is a lot less writing. But because of that, there's a little bit more room for mistakes. So you have to kind of make sure you're paying attention and double check. 3v to the second power doesn't have anything to combine with. Negative 4v and negative 3v is negative 7v. And positive 4 doesn't have anything. So there's our answer there. If you see, we got the same answer up above when we made our boxes. We did the same work essentially, we just organized it differently. I'm going to do the same thing here with B. So this one's kind of more you write it as you go versus the other one you do a lot of setup and then it comes together pretty nicely. 7x times 6x squared, 7 times 6, 42. And x times x squared is x to the third. 7x times negative 3. 7 times negative 3 is negative 21, and x make x squared. 7x times negative 4. 7 times negative 4 is negative 28, and x stays attached there. Okay, now in red, I'm going to take my 6, and I'm going to say 6 times 6x squared is 36x squared. See how I line my x squareds up? 6 times negative 3 is negative 18x, and 6 times negative 24, or negative 4 is negative 24, said the answer. And now I'm just going through and putting my like terms together. So 42x to the third, and then negative 21 positive 36. Signs are different, so we subtract and keep the sign of the larger number. So in a calculator, you could do, 36 minus 21. And that would give you positive 15. And then this one we're adding up, so this is going to give us negative 46x, and then negative 24. And again, we got the same answer. We just organized it different. Now this triple distribution one is crazy, but we just take it one piece at a time. So I'm going to do blue. I'm going to say 5x squared times 3x squared. So another way to organize this is you can do lines underneath. So watch. 5x squared and 3x squared is 5 times 3 is 15. And x squared makes x to the 4th. 5x squared times 2x. 5 times 2 is 10. And x squared and x make x to the 3rd. 5x squared times negative 3 is negative 15. And we're going to leave that x squared attached. So instead of doing 3 rainbows, right, like that, because that can look messy, I just did 3 lines. So negative 7x times 3x squared. Negative 7 times 3 is negative 21. X and x squared is going to give me x to the 3rd. So I'm going to get negative 21 x to the 3rd. I'm going to write that there. Negative 7x times 2x is negative 14 x to the 2nd. And then negative 7x times negative 3 is going to give me positive 21x. And then with my 8, I'll use green. So I got 8 times 3, which is 24x squared. So positive 24x squared. I have 8 times 2, which is 16. So I'm going to get positive 16x, and 8 times negative 3, which is negative 24. And then all I have to do, so I'm going to add my blue, purple, and green together. So my blue, my purple, and here we're just taking care of the numbers. My green, just all 3 of those together. And then these 2 together, which will be positive 37, and then negative 24. So I just went, what do I get when I put those together? What do I get when I put these together? What do I get with this? What do I get with this? Okay? So that's the 3rd way to do it. And if you wanted to use the distribution lines, you could have done that. It just, see how messy it starts to look. So anything bigger than 2 that I'm multiplying, I like to write little lines underneath. That's just preference. Okay, and then I'm going to show you what expanded looks like, and then that'll be the end of these notes. I would recommend, if you would like, practice each kind or pick one that you like. But here's what expanded looks like. I'm going to take v. I'm going to multiply it with 3v minus 4. So I'm going to take my first term, and I'm multiplying that whole thing with 3v minus 4. I'm also taking my negative 1, which was my term here, and I'm multiplying that with 3v minus 4. So I'm gonna do my first one. Let's see, I'm gonna use a different color. V times 3v, 3v squared. V times negative 4, negative 4v. Then I'm going to do my second one. So this one's a little bit more writing. but it's similar to the double distribution. The difference is there's you can you expand it out so you can see where each thing got from. So negative 1 times 3v, I'm going to do negative 3v. Again, I'm lining up my like terms just because it makes it easier to combine at the end. Negative 1 times negative 4, positive 4. And now I can combine 3v squared minus 7v plus 4. So again, for expanded, I'm going to take 7x times this whole thing and I'm going to take 6 times my whole thing. You don't have to know how to do each of these ways. You have to know which way would work best for you and develop that way. So now I'm just doing 7x times 6x squared. I'm getting 42x to the third, 7x times negative 3x. I'm getting negative 21x squared. 7x times negative 4, I'm getting negative 28x. In my second set, I'm doing 6 times 6x squared, and I'm going to get 36x squared. 6 times negative 3x, negative 18x. 6 times negative 4, negative 24. Remember, when we combine, we're just counting up how much there are. We're not changing our exponents. So this is going to give me positive 15x squareds. This is going to give me negative 46. You'd think I'd memorized it by now, but negative 46 x's. And this is going to give me negative 24. All right, and then finally, so I'll highlight just so you see where my numbers are coming from. I'm doing that one times this whole thing. I'm doing negative 7x times everything I have in red. And I'm doing 8 times everything that's in red. So I'm saying 5x squared times all this. Saying negative 7x times this whole thing. And I'm saying 8 times that's a minus 3. I've got to be aware that that's not plus. Just it's where it lined up with my there, just shift those over a little bit. Okay. Now I'm just going to do these one piece at a time. So I'm going to do my first piece. And then I'm doing my second piece. And then I'm doing my third piece. And I'm always lining up my like terms. So 8 times 3 write my answer in purple. So this didn't add up with anything, so it's just 15x to the fourth. When I combine these, I get negative 11x to the third. When I combine all this mess, I get negative 5x squared. When I put these together, I get 37x and negative 24. Okay, so a couple notes on this. The math itself is consistent with everything we've already learned how to do last semester. You are multiplying and following your exponent rules for multiplication. So you multiply your bases, add your exponents, and then once you've done all the multiplication, then you are adding and subtracting like terms. You're combining your like terms, which is just combining your numbers. So there's really just the two steps to it, and there are three different ways that we've now seen to show our work or to work those out. So whichever way works best for you is what I'd like to see you do. The area model, where we're working with boxes, double distribution, where you kind of create your lines and do the mental math to multiply, or expand it out. You take the term, you split up the terms from your first group and you multiply it into your entire second group. Okay?